Let's see.
I struggled at first, but it was just kind of getting used to. I mean, to me, it was just one more step in calculating the z-score. You know, instead of dividing it by the one number, you divide it by.
Well, yeah, you divide it by the standard deviation of the variable.
Yeah.
But so like I'm doing that, and then like when we're trying to find like, and we can go through it, and I can tell you the ones I'm having issues with. But we're trying to find a probability that's less than something or greater than something. I type in the, I made this Excel sheet trying to follow Alex's example, and it's been working. But every time I try, I get wrong. I get answers different than what's in the answer score, and I check my math and everything, and just don't know why.
Well, it's not. I mean, it's not a big deal. We can just go over the. Oh man, we'll just go over it and then. Yeah, sorry, I'm struggling. Okay, yeah, whatever. We'll just go, and then whatever ones I have questions on, we can break them down.
Okay.
So number 4, sample size 4 are taken from a normally distributed 2011 sales data. What's the shape distribution of the random variable? Normal. Comes from normal ones to be normal.
Yep.
Number 5, same deal, right?
Yeah.
All right, and then number 6, what sample size N4 taken from the normally distributed 2011 sales was probability of the observed random variable being less than 40. Let me see, 16%. So you guys got?
Say what?
16%.
I did the decimals, but yeah.
I got 16% too.
Yeah, I just did I just left it in decimal form and 0.1587. So yeah, 16%.
Yeah. Oh, I did. I did this, but I don't remember how I came across these answers.
Say I got that one, but it's the next few where I get it from the what is it? 68, 95, 99.7 rule. I get it where it comes from there, but as far as calculating it, I don't understand how you calculate it, or if we even need to calculate it. Do we just use that percent rule then?
Yeah, I mean you can, but I know I did a formula on it. I'm struggling this morning. And did you use the like the app,
yeah. Now this one I did a while ago, so I can't really remember. It's not as clear in my head, but yeah, I used the app and just highlighted between, you know, the area.
Okay, yeah, because so it'd be like the same thing, just calculate the z-score, and then it'd be like the less than that 40 mark, right? Like that, like the z-score of 40.
Oh,
right.
I was reading it wrong.
For me,
that's where I went wrong. See, look at that. Different eyes, man. Different eyes.
But that's right, right? Just do the z-score like we did, and then we use the applet to.
Yeah.
Okay.
Yeah, I was reading it wrong. For some reason, I kept on thinking it was less than 35 and greater than 55. So I was trying to get the edge ones and add them together, like we had in one of the questions earlier.
Yeah. That's right. That's what you did, right, Andrew?
Yeah, 95.
Yeah.
Yeah, 95.
Okay.
Okay.
And then 7. 7's the same thing. 95. Yeah, we just did that.
Yeah. So I did have a question on 9 because this one. So I got. I know you guys did it a little while ago. I just started this one last night.
Oh gosh.
25.
Hate these hiccups, man.
Okay.
2.
And
And 50.
Did I save my
2.5.
Excel spreadsheet for this? There we go. Yeah, there we go. Let me see if this one's the one. I can't remember what I labeled my Excel spreadsheet as to when I set up to do these.
Oh. Wow. Okay. Okay. Now that I have the applet thing figured out with you guys.
Yeah.
Now I'm getting the right answers.
Yeah, the applet thing's tricky sometimes.
Yeah.
So sorry, real quick. So we're looking at the sample size to do it, but then to find the z-score, it's just the same as before. Like take the mean divided by, or the mean minus the standard deviation. No, geez Louise. Okay, the variable minus this mean divided by the standard deviation.
Yeah. So you have to get that special standard deviation for that variable.
Okay.
So the numerator is still the same. The denominator just
Yeah. And then the denominator is just the standard deviation divided by the square root of the number.
Okay. Just the standard deviation is 10.
Let's see.
Hundreds of 10. I just want to do this real quick. Make sure this is the right spreadsheet I built for it. The mean's 45, and the variable is
4. Sample size divided by
4.
the square root of 40.
4 divided. The variable is 4. 4 divided by the square root of 40, you said?
I thought so, but maybe I'm wrong.
What are we talking about?
Yeah, which question are you talking about? I'm sorry.
Oh, was I looking at the wrong one? I was looking at problem number 6. I had accidentally scrolled. You guys are on 9,
So,
right?
Are we on 9? Talking about 9?
Yeah, that's awkward.
We're doing less than or greater than 50?
So the variable size is 25.
There we go. Now we're talking.
And then
Square root of 50.
square root of 50. Jeez Louise. I know I did this.
Well,
No,
it won't be the square root. It'll be the square root of the variable size.
square root of variable size.
So you have the standard deviation of the normal data set, which is 10, divided by the square root of 25. And then you get your sample size standard deviation, which you just plug into your regular z-score formula.
Do you mind sending me your spreadsheet you built for that? So
Yeah.
I swear I built one, but I can't. This is like.
Yeah.
Would you mind including me on that?
Yeah.
Value minus mean divided by the square root of the standard deviation.
I'll just email it to the group.
Thanks, man. Maybe I didn't say that, I guess.
Okay. Okay.
Oh, buddy. Ugh.
Got it. Thanks.
Mm-hmm.
Yes.
So I'll also share my screen.
Open.
Whenever you guys open it, and I'll tell you how I kind of did things. So on the left box, you have the formulas to find the your value here. So it's just the z-score times your standard deviation plus your mean. Find whoops.
Okay.
And then I have this formula to find your z-score on the right column of that one.
Mm-hmm.
And it's just your value minus your mean divided by your standard deviation. And then over here on the right box, I have the finding the standard deviation of your random variable or your sample size.
All right. So let's do.
That makes sense?
Yeah, let me plug this in real quick.
For some reason, mine's taking a while to download, but I'll let you know.
Okay.
So so the mean's 45. Standard deviation was 10, right?
Which one are you doing?
8. Are we on 8 or 9?
We're on
No.
9.
9. So the sample size is 25, or just for like the equal to what I'm looking at. So for 9, sample size would be 25, but the mean was 45, right?
Yeah.
Standard deviation was 10 to find the z-score. And then the 25. So the z-score was -2. Means 45, standard deviation. And well, that gives it backwards. And then we just put it on the applet.
Yeah. So I think we're a little behind, not behind. Oh yeah, behind, I guess. So I'm gonna do my screen share again. And so this one right here on the right,
Here, give me a second.
that's where we're finding the standard deviation of your sample size. So before you can plug anything into your z-score, you need to find your standard deviation of your sample size.
Mm-hmm.
And then you plug that standard deviation. So this one right here is your sample size is 25. The regular standard deviation of the actual.
Do you mind making just the spreadsheet bigger? I can't see it. It's like not very clear.
So is that better?
Yeah.
Okay, so here we are. So this table right here is to find your standard deviation of your sample size. The value is your sample size. The standard deviation is your standard deviation of your data. So your original data set,
Okay,
which is 10.
10.
And then that gives you, and then you do the formula, which is the standard deviation divided by your sample size square root of your sample size.
Okay.
That gets you your standard deviation of your sample size. Then you plug that in over here under the standard deviation, and then you plug in your 50 because that's what you're measuring, whether it's greater than 50. Yeah, and then you still have the 45 as a mean, and it gives you a z-score of 2.5.
And then you plug that 2.5 into the applet.
Yeah, and then you just highlight the right side because that's you're measuring greater than 50, and it gives you 0.0062.
Okay.
I guess if you do like the actual mathematics, don't use the applet, you get 0.00621.
Okay.
Did that all make sense to you guys?
Yeah. So
I'm pretty terrible at explaining things, so let me know.
good. And then, so then my standard deviation would be 2. So I plug it 2 in over here. And then my z-score would be -10, right?
Your z-score should be 2.5. What's your value? Do you mind screen sharing?
Yeah, let me. Here we go. Oops, no, we don't want to do that. Just application window. Is that right?
Yeah, that's good.
So 10, and then the value for question 9 is 25, right? Yeah, so 25. And then that gives me the 2. So do I put, and then for this z-score right here, I put it as 2 right here?
Yeah, and then under the X slot on there, you're going to change it to 50.
50.
Not that one, the other one, under the z-score
this one
column. Because that's the value you're measuring is greater than 50. Yeah. Then you're going to get the z-score of 2.5.
That means I just deleted that. Okay, so this one's, it's greater than 50. And then our z-score is 2, mean, and then our standard deviation here is 2, right? And then for this one, or does it stay 10?
That one doesn't matter. That's only if you're finding your value. We already have the value. That's what we're finding, like the 50 or whatever.
So
if we have the z-score, the mean, and the standard deviation, we're trying to find x.
Oh, okay. So now I just plug in the 2 to the applet.
You plug in the 2.5 that you get in the z-score column.
2.5.
Yeah.
So
I haven't had that much Excel experience, so I apologize if
it's all right.
It doesn't make a whole lot of sense.
Dang it. Which one of these sorry guys, I'm like was up way too late last night. I can't even think straight. That's fine.
It's all right. I've been up since like 2 a.m. So I start work tonight, so I'm trying to get back on a night shift schedule.
My little brother works at the FBI building, Pocatello, and he has that same issue.
Oh yeah.
Okay, I'm sorry. I can't find my applet, so let me go back to chapter 6 and grab it from there.
Yeah, that's where I had to grab it.
Group quiz for today. There's a link to the applet inside the group quiz.
Oh, perfect.
I'll have to open that up. Let's see.
There we go. So then the z-score is 2.5.
Yep, then you just highlight the right side because you're just measuring greater than 50. Should give you area or a mean or a probability of 0.0062.
Yeah.
Okay.
So yeah, perfect. And that was, let me check the answer key. For 9. Yeah. Okay, cool. Cool, man. All right. That was I'm sorry, that was a struggle.
That's all right, man.
All right, next question. Let me see. The sample size n equals 4 taken from the right skewed 2010 phone data cells. What is the shape of the distribution? Well, it's skewed right because the sample size is small and the parent node is skewed right. So
yeah.
Yeah.
Then 11 says sample sizes of n equals 40 are taken from the right skewed 2010 P phone sales data. What's the shape of the distribution of X? Whatever. It's approximately normal because of the central limit theorem. Yeah, because n is greater than 30.
And central limit theorem is the answer to the next question.
Yeah.
Yeah, perfect. And then this is just the same thing, right? This or the same thing we did with that Excel spreadsheet that you sent us, correct?
Well, 13. It's not actually like any sort of calculation.
It's just asking if it's possible to use the probability applet to find the probability for it, and you can't because the normal probability applet is just for normal
And not
distributions,
right skewed.
and not right skewed or left skewed.
Yeah.
That makes sense. Okay.
And then 14, 15, that's when we can start doing some math.
Okay. 14, 15, that's where this comes in, this other deal comes in. So sample size of 4.
Well, sample size is 36 and 14.
All right, I'm sorry. 36.
You're good. You're good.
You're looking at 13, not 14.
Looking at 14. You were looking at 13. Or I don't know. Someone was looking at something.
No, you're right. I'm an idiot. Get my life together. 36 means 40. Here's z-score of -2.
Z-score of -2.
Yeah, that's what I got. Is that what you guys got?
Oh,
I have a question. If it's right skewed, how do we find the probability if we can't use the applet?
Oh, you know what? That's a good point.
There's a calculation, I believe. Let's see.
Yeah.
Do we still use the?
But well, even if it's right skewed, but if the variable is greater than 30, right? That the central
Yeah.
theorem.
That's normal.
Right. That's right. Okay, so we can use the applet. We can plug that z-score in.
Yeah.
And
So
okay,
the deviation was 12. Sorry, I had the wrong deviation in there. So you got the mean of 2. Oh, I got a z-score. Oh, I had to change that mean too. 40.
I got 95.45.
I got a z-score of -1.75.
Oh, really?
Yeah. Let's see if I have all my information right. So yeah, the value is 36.
I got you.
Value 36, standard deviation is 12. That gives us a sample size standard deviation of 2, correct?
Yeah.
And then the x variable is 36.5 that we're measuring for, standard deviation 2, and then our average is 40, which gives me a z-score of -1.75.
40, huh? Let me see. 36. Oh, 36.5.
Yeah.
So that goes.
So I got 0.9599.
Okay, let me redo this. You said your thing was negative. Your z-score was negative. Set 175.
-1.75. Yeah.
Okay, I did 36 instead of
36.5.
Yeah. So that's where I went wrong. Yeah, -1.75.
And I checked the homework answer key, and we were correct. It's 0.9599.
Yeah, cool.
So 15. So this is where we have to do a little more mathematics, and we have to do. What is that?
So this one's we're just doing it's like minusing from 1, right? we can find. We'll just do the same information.
We'll
But
just do 1 minus each.
so the probability between 37 and 42. So we do 37.5 on negative 125, and then if let's see if 30 or 42.5 is positive 125. Yeah. So we'll just plug that into the normal. The z-scores of negative 125 and positive 125.
We just do it between. It's between those two. So 0.7887.
Yeah.
The same answer. Yeah.
Yeah.
Okay.
So, because they did it. I mean, like the answer key has
The mathematics written out. Yeah.
but that's I don't know. It seems like a lot of extra steps you don't need to do.
Yeah.
Love you.
Yeah. Okay. Cool. Yeah. Down to do that quiz now then.
Yeah, let's get done. I've actually started some of it.
All right.
Pretty simple. I've gone up to question 7. I've finished.
Okay. Use the normal probability outlet. 1.358. What is normal curve? So we're just going with for number 3, it's just the middle section highlighted, right?
I think so. So it's
Just put in that it's not the middle. I went to the right and to the left.
To the left? Okay.
Yep.
So
So
did you get
1.1745.
yeah, that's what I got.
So 174 or 175?
Actually, I'm looking at this. We round to the third.
Yeah. So we're
Yeah,
0.175.
5. I was
So 0.175.
1.45. Oops. Yeah. Okay.
So 175?
Yes.
Okay. Which of the following would have a smaller standard deviation if 9 observations are randomly drawn from the population?
I wasn't sure on this, but I put distribution of sample means, but I could be.
Which of the following will have a smaller standard deviation? Oh, a smaller standard deviation if 9 observations are randomly drawn from a population. The distribution of individual operations.
Wouldn't it be the individual operations?
But isn't the larger your sample size, like the law of large numbers, right?
Oh, the
Larger the-
smaller the deviation will be. You're
Yeah.
right. Sorry. You're right. That makes sense.
So what did you say?
Well, according to the law of large numbers, the larger your sample size, so your standard
Yeah.
deviation.
What did you choose for
Well,
your?
the smaller your standard deviation will be.
No.
So what did you choose for your? So you chose the distribution of the sample means.
Yeah, standard or the random variable.
Yeah, that's what I.
Yeah, that's what I was thinking. Okay.
All right, which the following implies that the spread in X bar decreases as the sample size increases.
Wait, implies the spread of the random variable decreases as the. Is that the central limit theorem?
That's the law of large number because the spread,
Oh,
and
no.
in other words, we're talking standard deviation, right?
Yeah, we just said this.
Yeah. That's okay.
Yeah.
Use the following info to answer the next 4 questions. Just skip that. We can reference it if we need to. Question 6. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Find your answer to the 3 decimal places. So the mean is 150.8.
160 minus 150.8 divided by 8.8. Get your z-score.
She got what? 160. And what was your z-score?
1.046.
Yeah, okay, that's what I got.
Sorry, you guys got what?
1.046.
Okay, yeah, you're right. I just didn't round, so I was like, that's not the number I got.
Yeah, okay.
the probability that a randomly selected student will score 160 on the
Here, applet.
So then we just plug. That's just using the applet, right?
Yeah, just and make sure you're only selecting the right part of the graph. I think that's Z-score. I got 14.8.
Yeah, me too.
We're doing decimals here too? Yeah, okay. That's what I got.
Yeah.
That's where I stopped. I haven't done any more than that.
Okay. A random sample of 5 students was selected to take the GRE. Their scores are as below. What is the Z-scores corresponding to the sample mean of these students' scores? Round your answer.
We just find the mean and the standard deviation of these numbers, right?
Yeah, we need to find the average of that sample size, or that, yeah. And the average I have is 160, just so happens. Things easy.
Yeah, 160. So it's just, and then, well, so that's the mean, and then the standard deviation. STD is 10. I got 10.04 or 0. I got 10.05 for my standard deviation.
What are we, okay, remind me, what number are we using for the square root of?
The square root, you use the standard deviation, right? The square root of the standard deviation.
You use the square root of the value you're using.
It's looking, looking for our Z-score. We just need the standard deviation, the mean, and the variable, right? So our
Z-score corresponds to the sample mean. So the sample mean, then we would just do the value as 160.
Yeah, and then the standard deviation for those numbers was 10. Sorry, I just had it somewhere in one of the million spreadsheets I have. 10.05 is what I got.
Well, your Z-score, 10.05?
No, for my standard deviation.
Okay. Will you share your screen and walk me through what you're doing? Is that okay?
Yeah. Let me get back to this. Okay. So these are the numbers we have, right? For the random sample size. And so I just did the average. This right here is the average. So this is the mean. And then this one I just did a formula for standard deviation of these 5 numbers to get that.
Okay.
Sorry, could you walk me through that one more time? I was looking.
Yeah.
So we did the.
So the mean is
160.
160 because I just added all these together, and then I found the standard deviation of these from the mean. Well, that can't be right. 10. That's what let me see. 3 to 7. Standard deviation from the mean. That can't be right though.
You have a 149 and a 175.
Weren't those numbers in there? No.
In your standard deviation.
Oh yeah. Yeah. Okay, you're right. I'm sorry. Yeah. So that's
Standard deviation is your median. Is that what we're talking about here?
From the mean. Yeah. So that's the standard deviation, and then I plugged it into. Let me share my entire screen. So that was my standard deviation. So I plugged it into this, and then I need my variable, which was, what is this z-score to, well, don't we need a variable to find the corresponding to the sample mean of this? Oh, so then we'd have, so it'd just be 160, right?
I'm saying the z-score I get there is 0 because your variable and everything is 0.
But would that be right? Because that's
when I did the standard deviation of mine, I got 8.9. So I'm just wondering.
But the standard deviation, even if it was 8.9, having the mean and the variable the same,
Be 0.
it's going to be 0 each time.
Yeah.
So, let me see. Let me read something in the book real quick. Because that can't be right. Okay, the mean of, it has a mean of whatever. Okay. Then the standard deviation of the standard deviation divided by the sample size. So that's, I didn't do that. So plus this divided by 5. So the standard deviation would be 2.
Wouldn't it be the square root of 5?
Oh, yeah, my bad. Ooh. Square root, perfect. So 4.49.
4.4, probably 4.5 if we went around to like 1 decimal.
Okay, 4.5. The standard deviation.
Wait, hold on. You got a different one than I did. Oh. No, yeah, you did the. Oh, it's because I did 10.05. I rounded my standard deviation.
Oh.
10.05.
And what did you get though?
4.4994, 4.49449665 because I rounded it up to 10.05.
Okay. Yeah.
I got 4.019, and that's because my standard deviation of the sample, the 5 sample numbers.
8.9. Yeah. So
But how did you do your standard deviation?
I just put stdev.p. Use that formula.
I didn't do the dot P. I just did the normal standard deviation.
Oh.
Should I do dot P?
Okay. Well, let me see, because
P probability Titan.
the normal one, it says this function is available for compatibility with Excel 2007 or earlier. So it really isn't compatible anymore with the version of Excel that I have, so I just don't use it. I use the .p one. I don't know, but I could be totally wrong.
Let me see what estimates the standard deviation based on sample, entire population given as arguments.
I guess you want to use the sample one, right? This is a sample.
S.
Yeah, because when I do .s, it does give me 10.04988.
Yeah.
Okay,
Cool.
well, use that, and that gives me a final answer of 4.494.
Yeah.
Oh,
So,
we're on the same page, people. This is good.
So, but the
yeah.
problem I'm still running into is the z-score being 0 because it's asking for what's the z-score of the. Oh, I'm on chapter 6 right now. That's why I can't find anything about it.
But isn't it just a 4.494? It's asking for the z-score, the sample size, right?
Yeah.
Wouldn't that do it? Isn't it 4.494?
That would be
That's
the
the standard deviation of the sample size.
sample size, not the z-score.
Yeah.
Then we could put 0.
But let me just look real quick.
The question says, what's the score corresponding to the sample mean of a student's score? So sample mean, that's what we got. I don't know.
It's like
Guess
the,
it's 0.
okay, let me see here real quick. So like the z-score would be 0. Makes sense.
I guess. And the normal probability applet that gives basically each side is 50% probable. Or
Yeah, I guess if you're going off the mean would be right in the middle, so that does make sense.
Yeah.
I'm gonna go ahead and go with that. I mean, that's just we did the. I mean, we followed the steps. It just happened to be 0.
Yeah.
So 50% is the answer to number 9 then.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Yeah, 50%.
So it's 0.5.
So 0.5.
But the thing that's freaking me out is it says like round your answers to the 4th decimal place.
I know. I don't. But the thing, I don't know. According to all the calculations we have in the books, like we haven't done anything wrong that I can think of.
Yeah. Let me see. Probability involving mean.
In chapter 6 or chapter 7.
Value minus the mean. Let's see here. So the z-score for the mean is the value minus the mean divided by the standard deviation. Well, that'd still be 0 because if the mean and the value are the same.
Mm-hmm.
0, and that's good.
Right. The z-score has a normal distribution. That is mean. The mean is 0. So yeah, because that's the this is the formula we'd use, right?
Yeah. Yeah.
All right, cool. I guess we'll find out. Maybe I don't know.
Yeah.
Just,
so let's just move on and try and finish the next 5 or so questions.
Yeah. So the next one, approximately normal, since the random sample is.
That's what I have.
Nope. Approximately normal. Okay.
What is the mean distribution of the sample for all possible sizes of 81 that could be drawn from the parent population? What is the mean?
Well, isn't it 3.5 still? With a large enough sample size, you're going to have the same mean as the parent population, aren't you? With the sample size that big?
It'd just be the mean would be the same for all of them, you're saying?
Correct me if I'm wrong, but since your sample size is so large, 81, it's going to be pretty close to the mean of
Your actual mean.
Yeah. Choose 3.5.
Oh, sorry. I didn't realize we had information up here. I was like, where are you getting this 3.5 number, man?
Yeah, that's what I was confused too, actually.
Yeah, so yeah, that would make sense. So,
yeah, and this one it says round your answer to 1 decimal place. That makes sense because GPA 3.5.
Well, I mean, you can calculate it too, because
so we can just throw this into that same spreadsheet you had, right, Spencer?
Yeah, because your random sample of n equals 81, so just throw n 81. Your standard deviation is 0.7. Give you standard deviation of 0.007.
Mean 5. value of 81, right? Whoa, I don't know if I did that right.
Oh, it's just
Because my z-score came out to be like 1100.
1100.
Yeah.
Oops.
So, but we can just, what we're doing here is we just plug it into the stuff that you sent us, right, Spencer?
Well, actually, I don't think so, because we're not trying to find the probability. We're just
We're
trying
just trying to find the mean.
the mean.
Oh my gosh, guys, I'm sorry.
Yeah, no,
You told us this answer like 10 minutes ago. Oh,
yeah. So, yeah, 3.5. I think that's correct.
Alright.
The law of large number stuff. All right, we can move on.
So the standard deviation is just 0.7, right?
Oh, this is the distribution of the sample mean, so this is different.
Oh, so this one would be the 0.07.
Yep. Yeah, the 0.0778. We're doing it 3 though, so 0.078.
Yeah.
That sound right to you, Andrew?
Yeah, wait, where are you getting the 7, 8? The last two?
So we're doing the sample size standard deviation now.
Right. You plugged it in, so
Yeah, plug it into the formula.
so that's for 12.
Sorry.
Say that again?
That's for number 12.0.
0.078.
That's
Okay.
just what Spencer sent us, where you put the standard deviation of 0.7 and the value of 81.
Yeah.
Cool. All right. What is the probability that the mean for the GPA of 81 randomly selected students will be less than 3.3? So 3.3 is our variable.
Yeah.
I got
-3.3.
2.
5.
I got a negative 2.570, 2.571.
Yeah, I got negative 2.56.
Me too. So
This is using the 0.07. Oh, I
8.
should probably change that to 8 instead of 778. Okay, yeah, 2.56. If I got you.
and then it's probability of it being lower than 3.3. So it's just the left half.
Yeah, it's like 0.5%. It's super.
I got 0.01. Oh no, I'm sorry. I had
You have both of them highlighted. Yeah.
I got 0.0052. Is that what we're talking? 0.0052?
Yeah.
Yeah, so you answered 0.005. You answered to 3.
Yeah.
You round it to 3.
Yeah.
Round what to 3?
3 decimal places. I'm sorry.
Okay. 0.005.
Hey, don't round that to 3. Oh man, that'd be crazy.
Yeah.
Yeah, when I said, I was like, I don't know if that's right. That would be
So
great.
basically, if it's greater, so we just select the different ones.
The
Right.
other two.
The other two, so 0.9948.
99.995. Because it's just that answer minus 1, right?
0.995.
Or 1 minus that answer.
Yeah.
Okay. So the U.S. Coast Guard assumes that the mean weight of commercial boats is 185 pounds. The previous value was lower. It was raised after a traffic, accident. The standard deviation of passengers' weight is 26.7. The weight of the random sample of 48 commercial boats passengers were recorded. The sample mean was determined to be 177.6. Find the probability of the random sample of the passenger having the extreme or more extreme, either above or below the mean. Then was observed in the sample.
So first we need to find the sample standard deviation. And our number is 48, so that's going to be squared. and then our
Square root.
sample mean is 177. So don't we take 177.6 divided by the square root of 48, and then we get the sample standard deviation.
So sample standard deviation I got was approximately 3.85.
3.85.
Yeah.
Sorry, what were the numbers you guys used for these? So the standard deviation is
0.7.
26.7.
And then the value was 48. So there's going to be 48
Oh,
commercial boat passengers.
you said you got 3.85?
Yeah, the approximate goes to 3.85381347.
Yeah, yeah.
But rounded it to 3.85.
So
And then, so are we, for our Z's, we're trying to find the Z score. What am I looking here? Find the probability that a random passenger will have a weight that is extreme or more extreme.
so
So
185
sample mean.
was the mean.
So are we putting the sample mean under our, and the Z score, are we putting our sample mean under our X variable?
Sorry, the mean under the variable.
Well, as a sample mean, then there's like a mean of the original data set, you know? So our sample mean was 177.6. So that's a sample mean of the 48 passengers
Oh, dang it. I think you used the sample mean, right?
under the mean,
Yeah.
or under the
Or do we use the
X variable.
X variable is the standard, is the regular one, right? The 177.
Yeah, and then the sample, or then the mean will just be the normal mean from the original data set,
Which was
185.
185. So did you get a Z-score of negative
1.92
008?
92208.
2208? Oh, I rounded up my standard deviation to 3.854.
Oh yeah, you moved the 8 before. Okay, so you got 1.922.
1.9.
Yeah, 1.922.
Yeah.
If you add the 84, then it gets to 1.920.
Okay. Yeah, that's what I got. I got 1.920.
Let's just do that.
Because we were supposed to round up our stuff to 3, or no, or do we not do our?
As accurate as we could be, I guess.
Yeah.
So I get.
We don't need to round the Z-score. You plug it in, and then your area probability. That's what we'll round.
Okay. So we'll do 1.922 just to be safe to get our.
With the Z-score. Yeah, I think that's smart.
Okay. And then we're doing the probability of it'll be above or below the mean. So that's just the two left and rights, right?
That's correct. And I got 0.0546.
Me too.
That's what I got, yeah.
So 0.55. 0.055.
Yeah.
0.055.
Did anyone submit it?
I can if you want.
I can do it. Well, yeah, someone else submit it.
Okay, I'll go ahead and submit it right now.
Let's see what we got. We got change.
Okay, we missed 2. And they were questions 8 and question 9.
8 and 9.
So it's our 0 and our 0.5.
Yeah, I didn't think that was right, but
Yeah.
So let me look in the book real quick.
Okay.
But if the mean
Doesn't make sense because we're missing something then.
Yeah. I don't know what we're missing.
So to find the Z-score, it'd be our random, whatever that X is, the random Jeez, what's it called? I'm just looking at it. Finding the area of the normal curve based on a sample mean. You know what? I wonder if, do you know what I think we might have done wrong. We took well, no, because the mean, let's see here. You know, we did wrong. It's 160 minus the original mean of 150.8 divided by the standard deviation 1.8.
Right. We use 150.8 instead of the 160 both times.
Yeah, that's what we did wrong. That's what I think we did wrong. Because
it was 150.8. I thought it was 160. Okay.
Yeah, so that was the issue. So 160 is our x, and the mean is 150.8.
And what was the standard deviation? It was because I had all my data is gone.
Oh, I got you. It was.
I know the one was 10.005, right?
Yeah, 10.
And then we had 5. Oh, not 53. We had 5. So that was 4.4, or was it 4.5 we did?
I got a z-score of
2.04.
0.915. But I might not have done that right. Let me look at this formula in the book real quick.
Okay.
Because it's 160. Oh, dang it. 160 minus 150.8, and then our standard deviation was 8.8, right? Standard deviation.
Standard deviation was. Oh.
Because I think we. Or do we find the standard deviation of just those 5 numbers? Or do we use the standard deviation from the 8.8?
So I think that's also where we might have messed up, because
Yeah, I think we did.
because we were using the random sample standard deviation.
You guys, my internet cut out.
Which is calculated from our regular standard deviation. So 8.8.
And then
My internet cut out.
Oh, your internet cut out? Are you on your phone again, or are you back? Oh, looks like he's gone again.
oh no. Divided by square root.
So just to catch up here, we got our sample.
I got
a random sample is 5. We have 5 scores.
yeah.
And we square root that, and we divide that from the standard deviation of 8.8, right?
8.8 divided by the square root of 5.
So we get like 3.94.
Yeah. Well, I didn't shorten any of these for the calculations, and then I did 9.2 divided by that 3.93548, and I got 2.3377.
3.993548. And then, so we had the 160 as our x variable, and our mean was 150.8.
Yeah.
So the z-score is 2.337704 or 7707.
Yep. So I put so we're rounding the thirds up to 0.338.
0.338. Okay. 0.338. And what was the question? We're trying to find between the two numbers, or
And then what is the probability that there will be that students will have, that 5 randomly selected students will have the mean grades?
Oh, what's the z-score? So okay. So
yeah, so just put the z-score into the applet. And
oh, let me start over here. Are
Alex,
you there?
Yeah, I'm here now. I'm having a couple internet problems. I'm lost. Where are we at? What have you guys been able to do while I've been trying to get back in?
So I'll show you. This is the share my screen. So the formula that I'm doing is this one here. And so this is the x, this is the mean, this is the standard deviation, and this is the sample size. So I just subtracted, this is the mean, or the random sample distribution minus the regular mean. So it's 9.2, and then the next number we need is the 8.8,
which is a regular standard deviation divided by the square root of the sample size.
Yep, and I got this number, and then I divided 9.2 by this number to get a z-score of 2.348.
Okay. And then you plug that into the...
Yeah, and then plugging that into the app generator, and then to see if it'd be bigger, I only highlighted this side. Right?
Yeah.
And then I got a...
0.0097. Got it.
Yeah.
Thank you.
That's what I got.
So what was the mean? Sorry, I'm entering the other stuff.
So our z-score is 2338.
2.338, yeah. And we selected which side? We're doing
the right side.
The right side, so it's 0.0097.
Yeah, that's what I got.
Okay. So we're into third, so it'll be 0.009.
Will you go back up to that problem, Alex?
Yeah,
because
sorry.
we're supposed to round it to 3 decimal places. So wouldn't that 7 make it
an 8?
No, I mean, wouldn't that 7 make the 9 a 10?
The 9 a 10.
Okay, go back to where you wrote it in.
No, this one?
Oh, we do this one to 4 places. Okay,
Yeah,
for a reason. Now I see why they asked us to do it to 4 places. Otherwise,
yeah.
it'd be okay.
Yeah, that's why I thought it was so weird. But I was like, there's no way it's 0.5 if they want us to round to 4, you know. But
okay, could I verify answers with you guys?
Yes.
So question 3 is 0.175.
Yes.
4 is X bar.
Yep.
Distribution of sample means.
Yep.
5 is a law of large numbers.
Yes.
6 is 1.046.
Yep.
7 is 0.148.
Yes.
8 is 2.338.
Yeah.
9 is 0.9 or 0.0097.
Sorry. Yeah.
Okay. 10 is approximately normal.
Yes.
11 is 3.5.
Yes.
12 is 0.078.
Yes.
13 is 0.005.
Yes.
Wait a minute. Get to 13. 0.0778, and then 12 is 0.078.
12 is 0.078, and then 13 I thought was 0.005.
The probability.
Oh, I must have. Number 13 is 0.005.
Yeah.
Okay, I put that for number 14. I'm all messed up. What'd you have for 14?
0.995.
You cut out. Say that once more.
Go ahead, Alex.
0.995.
Okay.
And then 0.055 for 15.
Yeah.
Okay. So who's going to submit this time?
I'll submit it.
I'll submit it. I've already done it.
Okay.
Yeah, I'm just waiting for it to load. Okay, we're good. 100%.
100%.
Yep.
Cool beans. Well,
Well, we got there. It was harder today, but we did get there.
I'm
Yeah.
glad. I was gonna do the homework early, and I'm glad I didn't because I was struggling, dude. It took me probably 45 minutes to wake up.
Hey, at least we got it done though.
Yeah.
So,
All right. Well, cool. I'll post this to the discussion board.
see you later.
Hey, see ya.
Bye.